Raise your hand if you got a definition for confounding variables. Allie?
An outside influence that changes the effect of variables.
Okay, an outside influence that changes the effect of variables. Anybody else? Different definition? Everyone defined confounding variables? Really?
I said a variable, well, we looked at that, but it said a variable that influences both the dependent and independent variable causing a spurious association.
Okay. Yeah.
If you look it up.
It's what you get if you look it up, but then there's lots of definitions when you look it up. So I recommend finding one that makes sense. So if you found one with the word spurious in it and you didn't know what that meant, maybe find another one. One that I've heard today that's pretty simple is an extra variable that you did not account for. An extra variable that you did not account for. So that is what brings into play what you were saying, Rose. What are some examples from our, what was the title? Who has it? What's the title of the experiment, Bailey?
Music's role in short-term memory.
I'm just going to call it music and memory experiment. So what was yours? What was your example, Rose?
That people were waiting on me to finish.
Okay, so pressure. Under pressure. It's a confounding variable. If you had done it without 3 other people staring at you, you might have performed differently. What's another confounding variable, Nathan?
The kind of music it is.
Well, that was actually one of the treatments that, or one of the factors that we intended. Howie?
The volume.
Okay, yeah, volume. That one hasn't come up yet today. It's a good one. Allie?
Watching the timer, made me nervous.
Okay, so that might fall under pressure, but in a different way, so that keeping maybe distractions. Is that what you're going to say, Bailey? Tayshawn?
Maybe trying to focus on the colors rather than the music.
Okay, so I think that's part of the process of the experiment. What is something that's a variable that you're not intending? You're not factoring in. Bailey?
Strategy, like of how to memorize.
Okay. So different people have different strategies, and that might play into people's different learning styles. There was one group that had a student that was colorblind. So if you're colorblind, that could be a confounding variable. This is a handful, maybe you thought of others, but hopefully you're starting to get the idea of what a confounding variable is. All right, we're going to go ahead and attack these notes. Our goal today is to be able to explain the importance of control, randomization, and replication. Within an experiment, we're going to take a look at one example of an experiment and identify all those parts. I've got the terms here defined for you. We'll talk a little bit about placebo, a few more terms, and an example to go along with those terms. That's an overview of the notes. I'll just go ahead and read folic acid and birth defects. So for several years, evidence had been mounting that folic acid reduces major birth defects. Doctors Seisel and Dudis of the National Institute of Hygiene in Budapest directed a study that provided the strongest evidence to date. Their results were published in the paper Prevention of the First Occurrence of Neural Tube Defects of Preconceptional Vitamin Supplementation. This is from the New England Journal of Medicine, and they tell us exactly where it is. This is an actual study that's been done that you could actually locate if you looked for it. So for the study, the doctors enrolled 4,753 women prior to conception and divided them randomly is important, into two groups. One group took daily vitamins containing 0.8 milligram of folic acid, whereas the other groups received only trace elements that included minute amounts of copper, manganese, zinc, and vitamin C. A drastic reduction in the rate of major birth defects occurred among the women who took folic acid. So 13 per 1,000 as compared to 23 per 1,000 for those women who did not take folic acid. In contrast to the observational study that we've done earlier, this is a designed experiment and does help establish causation. The researchers did not simply observe two groups of women, but instead randomly assigned one group to take daily doses of folic acid and the other group to take only trace elements. So the control. Good experiment has a control. The doctors compared the rate of major birth defects for the women who took folic acid to that of the women who took only trace elements. Good. Randomization. The women were divided randomly into two groups to avoid unintentional selection. Yes, bias. Replication is another key element to a designed experiment. So a large number of women were recruited for this study to make it likely that the two groups created by randomization would be similar, and also to increase the chances of detecting any effect due to folic acid. So as with our experiment, you're the third group that has done this. This is an experiment and it was repeated in 4 different groups at a time, so replication was there. In the language of experimental design, each woman in the folic acid study is an experimental unit or a subject. An experimental unit or a subject. When we're talking about humans, we call experimental units subjects. That's what this stuff says right here. Right here, down here. Flip it over. One of the most common experimental situations involves a specified treatment and a, Howie? Yes. And a placebo, which is an inert or innocuous medical substance. Technically, both the specified treatment and the placebo are both treatments. So they are treatments. The group receiving the treatment is called the, there you go. The what? Somebody guess? The treatment group. Fancy. And the group receiving the placebo is called the control group. In the folic acid study, the women who took folic acid constituted the treatment group. And those women who took only trace elements constituted the what?
The control.
Yes. The control group. Now for our next 4 terms: response variable, factors, levels, and treatments. So these are the elements of an experiment. You have a response variable. That's the characteristic of the experimental outcome that is to be measured or observed. What was our response variable in our experiment?
The amount of colors you got.
The number of colors that you could remember. Right, that's your response. The factor is a variable whose effect on the response variable is of interest in the experiment. What was the factor in our experiment?
Who was being distracted?
That was a confounding variable. The distractions were a confounding variable. What was a factor? The type of music. Okay? Now I'm going to draw two lines between factor and explanatory variable. You'll find in statistics, in some places they use one term, and in another they use a different term. In the textbook they use factor. In our district assessment they use explanatory variable. They're the same thing. Okay? So the explanatory variable in our experiment would have been what type of music. Then we have levels, the possible values of a factor. So those levels would have been country, rap, classical, or, well, no music was the control. And then the treatment is each experimental condition. In our case, it was very simple, so it would have been the same thing. The treatment and the levels would be the same. In this example below, you'll see that there's more going on, and we'll have different treatments because we have different factors. So here we have an example. A medical research group wants to know if chemo or anti-estrogen treatment is better for breast cancer patients. The question is, which procedure prolongs life more? And so, survival time is the response variable. The type of therapy given is the explanatory variable. It may or may not affect the response variable. In this example, we have only one explanatory variable, type of treatment. In real life, you would have several more explanatory variables, including age, health, weight, and other lifestyle factors. So we've got the weight gain of golden torch cacti. The golden torch cactus, a cactus native to Argentina, has excellent landscape potential. Feldman and Crosswhite, two researchers at the Boyce-Thompson Southwestern Arboretum, investigated the optimal method for producing these cacti. The researchers examined, among other things, the effects of a hydrophilic polymer and irrigation regime on weight gain. Hydrophilic polymers are used as soil additives to keep moisture in the root zone. I could use some of this for my garden, I think. For this study, the researchers chose broadleaf P4 polyacrylamide, abbreviated P4. The hydrophilic polymer was either used or not used, and 5 irrigation regimes were employed: none, light, medium, heavy, and very heavy. And then we're supposed to identify the experimental units. Anybody identify the experimental units? The cacti, yes. How about the explanatory variable? What do you think? Amount of water, that's going to be one of our factors. We're going to put that, we're going to label that the irrigation regimen. I'm going to call it the regime, even though I'm not sure if that's how we should say it. Bailey?
Is B the weight gain?
Yes, good. The explanatory variable, the thing we're trying to explain, is the weight gain in those cacti. What is another factor other than the irrigation regime? Amount of light. No. It's actually, see, I saw the word light and it makes me think of light. Did you do that? Yeah, so this is the irrigation regime. It's none, light, medium, heavy, or extra heavy. But the other one, what's the other factor? It's the polymer, right? That helps keep the moisture in. For the treatment, each treatment is a combination of a level of polymer and the level of irrigation regime. The table depicts the 10 treatments. We could have developed this table on our own. It's not real complicated. All it is the 5 different types of irrigation method and the 2 types of polymers. And then they just paired them up. So no water and P4, that was treatment 1. Light water and no P4. So it's going to be no P4, and then the different types of water, and then there's going to be with P4 and the different types of water treatments. So you can see that there's those 10 different options that are the treatments. So you see the difference. With our simple experiment, there was only one factor. So the factor in the treatments, the levels in the treatments were the same. But when you have more than one factor, you're going to have a different, you'd have to make a table to describe all the different types of treatments. So those are your notes on experiment.